Fermat's last theorem, a mental retard's logical proof. My motto, plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. 1. 7 equals 4 plus 3. Therefore, 4 plus 3 divided by 7 equals 1. 2. 4 equals 7 minus 3. Therefore, 7 minus 3 divided by 4 equals 1. 3. 3 equals 7 minus 4. Therefore, 7 minus 4 divided by 3 equals 1. By the same principles applied to the Fermat equation, 4. Z to the power n equals y to the power n plus x to the power n. Therefore, y to the power n plus x to the power n all divided by z to the power n equals 1. 5. Y to the power n equals z to the power n minus x to the power n. Therefore, z to the power n minus x to the power n all divided by y to the power n equals 1. 6. X to the power n equals z to the power n minus y to the power n. Therefore, z to the power n minus y to the power n all divided by x to the power n equals 1. Lining the three equalities up plus the 1 and multiplying through by 7, 4 and 3 to remove the denominators, we obtain the simplified and compacted equalities shown. Note that the exponent we have derived mathematically is a square. In 8 we repeat the exact same process as 7, but algebraically, to obtain again simplified compacted equalities. Again, the power obtained algebraically is a square, and the nth power is only there as a consequence of the Fermat equation. X, y and z to the power 2n is in reality x, y or z to the power n, all squared, in keeping with the numerical derivation. 9. Now z to the power n times y to the power n times x to the power n is just z times y times x all to the power n, which is just z times y times x multiplied by itself n times, so in itself is trivial and has no mathematical significance, except when the three terms form a Fermat triple. Then and only then the four final equalities obtained in 8 are paramount and apply without exception. They are equal for all a plus b equals c for the integers. They are equal for all the infinitely many primitive Pythagorean triples and all of the infinitely greater number of their composites. 10. Equating the three algebraic entities in brackets in the three different ways possible will result in three Fermat-Bateman quadruple equations. They are square equations and consequently Pythagorean quadruple equations, including the one equation with a negative term. All this is well within the capabilities of any bright school student, unless of course their Christian name happens to be Andrew. 11. The nearest numerical equation to a Fermat triple for any power above the second is 9 cubed equals 8 cubed plus 6 cubed, which is in error by 1. Applying it to the four equalities gives the numerical outputs shown below, which are blatantly and clearly not equal. 1, 2 and 3a clearly demonstrate that the three unequal numerical results obtained reduce in a numerically logical way to produce the original cubic quadruple, including the 1 cubed we ignored in the first place. Considering that the original triple equation was only in error by 1, the four equalities are like a mathematical operational amplifier without feedback. By greatly amplifying the error, they are also a mathematical proof and truth machine. 12. The simpleton triples z squared equals y squared plus x to the power n would all satisfy the four equality equations given in 8. In Elementary Algebra for Schools by Hall and Knight, 8th edition printed 1904, page 364, we find the example 2. I have always wondered why they opted out by making z equals 1. Now I know. The intermediate step gets too large to expect a schoolboy back then to work with. I have reworked the example with xyz equal to 3, 4, 5, the base numbers of the well-known smallest primitive Pythagorean triple. 13. It has been conclusively demonstrated in 7 that any legitimate triple would satisfy the 4 equalities, which includes z to the power n times y to the power n times x to the power n. Every integer zy x satisfies z to the power n times y to the power n times x to the n at every exponent level. If a Fermat triple existed, then every exponent level less than that of the triple would also satisfy the equalities. Hence, Fermat triples would exist at every exponent level down to and including the second, a contradiction on 2 counts. 1. It has been proved that Fermat triples are not possible for the 3rd and 4th powers. 2. It is mathematically impossible to elevate a Pythagorean triple to a higher exponent level. Reductio ad absurdum QED.